Good morning, everyone. Welcome to the last lecture of AIbDSS 1 for this semester. There's still next semester, but for this semester, that's basically it before the exam. So today, what we're going to do is we're going to finish up discussing the logistic regression a little bit. This will take approximately like 10 to 15 minutes. And after that, what we're going to do is we're going to go into the exam preparation, right? So this will be the major part of today's lecture. All right. Okay, so what did we do last time? So last time we introduced the logistic regression as a form of hypothesis that can cater to classification tasks. We had then discussed the binary classification task of detecting a tumor of either being benign or malignant. All right. So a binary classification problem. And then we established that we need some other function than the linear regression that can basically take on y values or hypothesis values h theta of x that are potentially between minus infinite and plus infinite, and we need to compress them to the range of 0 and 1. And then we get a number between 0 and 1, and we decide based on a threshold that is usually 0.5 whether a tumor is benign if it's below 0.5, or whether it's malignant if it's larger than 0.5, right? So this was the basic idea. And we said, okay, we're going to need this new function, which is called a sigmoid function or logistic function, hence the name logistic regression based on the function. Again, a little warning, this is not for a regression problem, but for a classification problem. Nevertheless, the hypothesis form classically called from statistics is called logistic regression. However, we use this for a classification task. So we've done all that. And now, after we fix the hypothesis form, which you know is the first ingredient we needed, like if you remember in the linear regression, we said we need a form of hypothesis, and then we need a way to teach the model, right? And then I explained how it generally works with gradient descent, with the teacher or the trainer, as you might have remembered. And the trainer needs some things. The trainer, of course, needs the hypothesis to train the hypothesis form, which is you if you go into the gym. So that's you. And we said, okay, we fixed this. So we know us. This is now the logistic regression model. Like we have that, right? We have the hypothesis. We know we're going to use this function right here. And now what we need is we need to train it. We use gradient descent. And what do we need for gradient descent? Correct. We need a cost function, right? We need a cost function. This is the central part because we need two things. We need a way to evaluate how strong we are, right? So that we can like get better. So by meaning this, I'm of course talking about the parameters, right? The parameters that we try to find. So we try to find good parameters that actually make the model, that the final trained model better, the hypothesis form, right? So we start with a stupid model with stupid parameters, and then we train it to become stronger, to become better. And so we need a thing to evaluate that, which is the cost function, right? So we established that the cost function is a way of measuring that. And now we have a little problem because we have learned from linear regression that we could use this cost function right here that is already that I already destroyed. So and the important thing to remember is what a cost function does. So I want to zoom out a little bit on remembering this right here. If you look at this, so the cost function generally, and this is always true, is a function of the parameters. So this is really important. It's a function of the parameters, and it always expresses a comparison between the ground truth, which is our true value y, from the training data set. So you know we have training examples x and y. So x could be a vector of all our input variables. For example, tumor size, x is tumor size, and y is the true value, either 0 or 1. It can only take on values 0 or 1. We have a classification problem here, right? So remember, the true value y can only be 0 and 1. And then we have our hypothesis that can take on values between 0 and 1. This is very important. Like people confuse and say, okay, the logistic regression can only put out values of 0 and 1. That's not true. This is why we use a threshold to assign values. So we have a step in between. So what we're going to do is we're going to compare this value that can range between 0 and 1 to the truth, right? And as always, we want these two values here to be as close as possible because that will drive the cost function down. So the cost function is always designed that if these values are close to each other, that the cost goes down. It's really intuitive, right? And the same is true, of course, for all machine learning models. No matter if you do a transformer, if you train ChatGPT, doesn't matter. It's always the same. However, the cost function, the form of the cost function differs. And this is a pretty important one. So if we would apply the linear regression cost function, we get something like this, right? To this function, because we have a nonlinear function, this one, in the mix, right? So we just don't have a linear combination, right? We don't have the linear combination here. So this would be the linear regression. So for the linear regression, it would look like this, like our typical quadratic function. But we have G basically around it. Remember, this is the one that compresses our value between 0 and 1. So using this whole thing, so having the cost of this, like having the cost of this and our y, and using the cost function of the linear regression would result in something that we call non-convex, which is a problem because now we cannot go down the cost function and guarantee that we will go towards the minimum, right? So this is a problem. So what we need to do is we need to find the cost function that actually is convex, right? So we need a different cost function. So we have to get rid of this cost function, as I already have done here, right? So let's get another cost function then, okay? So, and I want to start with the intuition of this cost function, and it's pretty intuitive, like all cost functions are. So again, it doesn't look very intuitive. You would mean, hey, where's the comparison? What the hell is this? Where is y? Why is this that way, right? And it's pretty easy because y is here, right? So we have a binary classification. So this cost function is intuitively very easy, even easier than the linear regression cost function, although it might not look like this at first. So we have two cases, okay? We have two cases. Remember, we are comparing y. We're comparing y to our hypothesis output. This is all we do, okay? Bear with me. So what we need is we need y. And y can only have two values here. Our ground truth can have two values. So the first case we're looking at is when y equals 1, right? So when y equals 1, then what is the cost function? And it says here minus log and then h of theta based on x. Okay, so we know, okay, so we still have our two main important things. We have our hypothesis and we have our y. Okay, so we still have this, right? So don't get confused. Now, why the minus log thing around? And it's pretty easy. So let's first check this cost function for the case that y equals 1. So very important, we're just looking at the case that the ground truth, the correct value is 1. And now we compare our output. Now we know that our output is a value between 0 and 1. So what we could have done is we could have simply like used this function here and built the quadratic difference. So this would help us because the larger the difference is, the larger it would be because it's quadratic. The only problem is that we get a non-convex function. So we have to find just another function that pretty much does the same thing, that like penalizes, and this is very important. So we put a penalty on large differences. And the larger the difference, the higher the penalty. So we don't want a linear penalty because while we might like it if the value is, for example, 0.97 compared to 1, so we would say this is a pretty good model. The model is pretty confident, right? If the model spits out this value, the model is pretty confident. However, if the model spits out 0.01, we would try to avoid these cases like the plague, right? We don't want this at all, right? So we should punish this way harder, obviously, right? And not just by the plain linear difference, but by some other measures. So what we do is, it's pretty easy. So we're going to start with a perfect case. What should happen in the perfect case? And this is like how you can construct measures, right? The perfect case is if our model spits out 1. Like this is the perfect case. Perfect means 1 versus 1. So h theta of x is 1 and y is also 1, right? So it predicts perfectly. It's perfectly secure, perfectly confident that this is 1, okay? So in this case, we should have a cost function where the cost function, right, our cost function, cost of theta, is 0. Whatever the cost function is, this should be 0. It should be 0 cost. This is the perfect case, right? So we're going to start here at 0. So we're gonna have a function that starts at 0. You can see the value here is 0. If our h theta of x, which is our x-axis, of course, because this is the one input to the cost function, the other input is basically y equals 1. And then we can do it in a two-dimensional way, which is pretty cool. And here we have the cost, right? On the y-axis, of course, is the cost, right? So we have this, if this is 1, then the cost should be 0, and it's 0. And now we simply put in the minus log. So minus log, you see this looks like this, right? Because of the minus log. So it's a reverse log function. And this does exactly what it should be. Like the more we get away from the 1, the more we get away from the 1, so we get in this direction, the higher the cost in a nonlinear way. And that's it. That's it. That's the cost function. So it's just we put in minus log of this. And so the closer this is to 1, because of the property of the log function, we know that if this is 0, it will actually be infinite, right? So it never actually reaches 0, right? However, so we're gonna close up to this one. And what we're gonna do is we have this function and we're gonna near the costs onto 0. So if the costs get close to 0, if y is 1, very important, we're talking about the case when y is 1, then the costs get way worse. So that our actual algorithm avoids that. So it will say, okay, this training example we cannot classify this as y equals 1, or if it's 1 and we get something like this, like for example, let's say our training example, the truth is 1, right? The truth is 1. And during training, our algorithm says, hey, this is the cost, right? Says, okay, I have a parameter values that says the cost is like here, okay? Then we know this is a pretty high cost. So we need to get the cost down. So we need to move towards here, right? So we need to change the parameter. We need to change the parameter accordingly, okay? So it's the same thought as a linear regression, right? Just we have two cases now. So we can see that obviously cost goes to infinite if this reaches 0. And let's look at the other case. Okay, let's just quickly look at the other case. So now y is 0. The truth is 0. So in our example, this would mean a benign tumor. Okay, so y is 0. What does that mean? Okay, if y is 0, we just have it the other way around, right? We still have the minus log because we don't want this, but we always want it like this. But we just flip it. We just flip it around. So we take, instead of taking the minus log of the function, we just flip it around. And to flip it around, we just want it the opposite direction. So we basically now want it to start at if 0, right? If it's 0, it's 0, because then it's perfect. If our h of x predicts 0 and the truth is 0, our cost should be 0. That's pretty easy, right? That's the perfect case. So here the perfect case, here the perfect case would be if y equals 0, right, as it says here, versus our h theta of x is also 0. And this should mean cost of 0. Like, no matter the cost function, this should always be the case, okay? So what we're going to do is, when will this become 0? So we just do minus log of 1 minus this. So if we have 1 minus this, and this is 0, then we have log of 1, right? So, and here you can see it here. Like if this is 0, we have log of 0, which is 0. And here's the same thing. If we have this 1, and then that's it, right? So, and that's pretty much the whole thing. And we have this inverse function right now that basically does the same thing, right? So it's a minus log function, but of 1 minus theta, right? So 1 minus theta. So it's pretty easy. Now, so as you can see, if this is 1 here, in this case, in the case of y, so minus log of 1, which is the case if this is in case of y equals 1, we want this to be 1. So minus log of 1 is 0, right? So minus log of 1 is 0. Minus log of 1 is 0. Now here, we also want minus log of 1. The problem is that this, in the perfect case, is 0. So if we leave it at that, it would be the complete opposite. So we have 1 minus. And the larger this is away from 0, the smaller this gets. So that means that this right here gets towards 0, which means that the costs go to infinite, right? So it's the same thing, same logic, right? So it's pretty easy. And this is the cost function now for the other case, right? And that's it. That's the basic cost function. Now you might think, mathematically speaking, this looks a little bit heavy. Like, how do we compute it? It's not like in one beautiful formula like that thing. And you are right. So if you want, what you can actually do is you can put it in one cost function, right? This is optional, but you should use this cost function if you like, and I will explain it a little bit, right? So this is the cost function. This is the logistic regression cost function. So J of theta is pretty important. So what we're just doing is we're gonna combine these. We're gonna combine the y1 with the minus log and the y0 with the minus log. And let me explain this, right? Real short. It's a little bit of math, but it's easy math. Okay, so just remember that the minus gets taken out here, right? So we have, because there's minus here and there's minus here, we just take it out. So, okay, let's first examine this for the case of y equals 1, right? So let's first examine this if our ground truth is 1. Remember, y can only take on two values, 1 and 0. So if this is 1, then this says 1 time log h of x, x of y, blah, 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 right? So, okay, so if this is 1, then we have here, this is the part of the cost function if y is 1, right? And this is the part of the cost function that gets activated if y is 0. Now, if y is 1, then this is 1, and this cost function boils down to exactly the sum. Of course, we have to do this for all training examples, but this boils actually down to minus log h of theta x I and the sum. I can put the minus back in here and it's the sum. So this is exact the same as here. You can see this. This is exactly the same. So this boils down, because if y is 1, this here becomes 0 if y is 1, because it's 1 minus 1 and this is 0. So this is completely gone, right? If y is 0, let me just pop. If y is 0, right? If y is 0, this is 1, right? And if y is 0, then this is 0, right? Because, yeah, y is 0. So then this gets deleted and we take this part. And so if y is 0, this boils down. I can take the minus in here to minus log 1 minus h of theta x I bop. And that's it, right? And then the sum and 1 n. So I do this for every training example, of course. So this is just the cost of one training example, right? So I add this up for all training examples, right? So this is pretty much important. Yeah, and that's it. That's basically it, right? And here we have it, right? And that's the cost function. So basically what we do is we use that these values can only be 1 and 0, and we just multiply it by them. So it's a pretty neat math trick. So whenever y is 1, then this portion gets activated. Whenever y is 0, this portion gets activated. So we write it in one line, but they can never be both activated because y can only be 0 and 1. Yeah, and there you have it. This is the cost function. And now what we're going to do is we're going to do the same thing. We put it into gradient descent. And yeah, that's it. We put it into gradient descent. We take the cost function. We want to minimize this. We update the parameters. We have the same thing. As I said, this is globally the thing how to go. It doesn't matter because we just need the cost function here. The only thing we need is the cost function and, of course, the learning rate, right? Don't forget the learning rate as a hyperparameter. Don't forget it. And that's it, right? Now it's the same thing again. We just need our cost function, right? And for the cost function, we, of course, need the form of the hypothesis, right? So these are the things that changes. The general idea of using gradient descent doesn't change, right? We just have different cost function for different hypothesis types. So we first have our business, we have our business understanding, then we prepare the data. And from our business understanding, we know it's a classification problem, it's a regression problem. And then we try to think what kind of hypothesis would fit this, what kind of hypothesis form would fit this. Then we fix the hypothesis form, right? Then we also know how many x's we have in there, obviously, because, yeah, we can like decide what variables, for example, housing price, we can have number of rooms, we can have square feet. In tumor, we can have the tumor size, maybe the age of the patient, and so on. We can add all these variables, and this doesn't change, right? So because this h of theta, right, can be a vector as long as we want. Like h of theta is always a value. Like no matter how many variables I have, this is always one value, right? That is between 0 and 1. Yeah, that's it. And then we do gradient descent. And if this is optional, right? So if you want to know optional, right, this is optional. So you can look at the derivative, and basically the derivative boils down to almost the same. If we generalize it, almost the same derivative as the linear regression thing, right? This is like a cool thing you can like or not, but this is if we derive it, this is it. And if you look at this is how it should be, right? So basically what we do is we're going to update the parameter, right? If we update the parameter, so minus alpha, so it gets smaller if this is positive, right? It gets smaller if this is positive, and it gets larger if this is negative, right? So this is important. So first of all, what we do is we have the x value, right? We have this x value that has an influence, right? So this is like the vector. And what we do is we just take this and we just weight this, right? So we're going to have this hypothesis minus the true value, right? Multiplied by x, right? And that's it, multiplied by this value. And that's pretty much it, right? That's pretty much it. So the important thing is that this is for the j parameter, right? So we have to do this for every x variable. So this is important, maybe for your understanding. Now we have a parameter in front of every x variable, right? So no matter if we have like this linear combination looks something like this, right? X1 plus, let's only have two variables, right? So we have to get this parameter, right? So we have the difference between the whole output of the model, right? Minus the true value. So this weights the contribution, and then multiplied by only that variable, right? So how large is the variable value? This is very important. If j is 1, like if j is 1, then this is x1, right? So we only care about this variable. Now, if we do this for another parameter, like say theta 2, then of course j is 2 here, right? So we're going to multiply it by this. But this, of course, is based on the training example. Like we don't care for this. Like this is the training example value of only x1. So x1 of the first, second, whatever training example we're just at. So, and intuitively, what you can see, that's pretty great. Now, if the error, right, if the difference between these two here, if the difference between these two is small, that means that the change is small. Of course, if the error is really small, then we don't have to change the parameter that much. If this value is large, then the change will be larger. So this here is effectively a weight on theta change. And intuitively, the larger our error is, the more we have to fix, right? So basically, you can imagine the trainer coming in and say, look at you, pathetic loser. You have no muscle mass. We need to train harder, right? So instead of, oh, you need to tone your muscles a little bit, right? So funny thing is that toning your muscles is actually harder than training at the first. But yeah, people who work out know this. However, in this case, if the difference is really small, that just means we don't have to pay that much attention to this change because the parameters were pretty good with this parameter, right? And of course, depending on the x value, so we multiplied by the x value because this is how the model works. Like we multiply this parameter by the x value. So if the x value is large, then this will have a large impact on the output, right? And this is why we also have to multiply it by the x value. Like if the x value is 250, even small changes here can lead to pretty large changes in the output of the equation. This is why we have to weight it by the x value, right? So this is logically, right? And if the X value is like 0.01, then it doesn't really matter, right? So it's still small, right? So, and this is how we balance all things, right? This is how we balance things. Okay, now, last thing before we go to exam preparation. Let's have a look. So last thing for exam preparation, what we do is we have the one versus all classifier idea, right? We have the one versus all classifier idea. And this says that we have like, if we have more than two groups, so we've only talked about binary classifiers until now, right? So what I could imagine is that we could have like, what if we have three classes? Can we still use it? So how are we going to use a classifier with three classes? It's pretty easy. We're going to use one versus rest. So we always act as if there are only two classes. For example, what we have to do is, so we build three models. We build, instead of one model, we build three models. So we build a model for the triangles, right? And this model assumes a binary classification between the triangles and everything else. So we put the crosses and the squares together to one group. And you can see here, the bubbles, right? So they form a new group called the bubbles, right? Very popular. Now, if we do a model for these, we're going to just summarize these together as one group. And now they are the bubbles, right? And the same is true for the axis. So we have the axis and the rest is the bubbles. And we train these three classifiers, right? And whichever classifier has the highest value, the largest value, we say this is it, right? So this is like the possibility that for this, we always put in the same X values, obviously. So for a set of X values, we're going to use this classifier, and there is a number between 0 and 1. Then here is a number between 0 and 1, and here's a number between 0 and 1, and the highest number wins. This is the highest like score we can have, and this is it. Right. We will discuss this once again in deep learning, where we actually tweak it a little bit. By tweaking is a high word. It's actually, we just add these numbers up and divide them by the total so that we get like values that add up to 1, basically. So we have like, again, sort of a probability, which I really don't like, but it's like how people think. And yeah, and that's it. That's one versus all classifiers and how you can do it if you have multiple classes. All right, cool. Like again, if you have questions of this, you can ask this after the lecture, right? But now I want to go to our exam preparation, which you all been waiting for, obviously. Let me just real quickly put in the slides. Pop, 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 pop. All right, so let's switch it up. So you should now see, do you see the monitor? Not sure what you see at the moment. Let me see. Yeah, you should see the monitor. Okay, you should see it. Yeah, sorry. Just have to check because if sorry. Can I have the laser pointer, please? Yeah, okay. All right, so welcome to exam preparation. Now it gets interesting for the most of you who don't care about the actual lecture, but more about the exam preparation. Okay, so very important. The first thing I'm going to say is, please, for the love of God, check out the exam information, right? I don't want to copy paste too much information here on the slides. So please check out the exam info, right? So it's very important for the exam, find all the infos of the exam. The sheets that you saw, like with all the info, will be exactly the same, right? They actually are modeled already after the real exam, right? I think even the times are the same. I will check it. So if there is some mistake, I will catch it, but it should be the same, right? And there are also some notes like keep answers short and precise and round to 3 decimals after the comma. So this will be exactly the same. So if you read it now, it will be the same, right? So okay, so this is it for the infos. And I will have a Q&A because some students sent me something, so we could discuss like questions about the actual process of the exam afterwards. But now I want to go quickly through the preparation exam solution, right? All right, let's do it. So the first one is easy because it's what I call a knowledge question. Like you just have to knowledge test. The important thing here, so I will tell you where people lost points. So this was once a real exam question. Now it will not be, of course. But so I try my best to highlight words in the questions. Now, if you fail to read the whole thing and lose points, this is obviously your fault. So it says shortly describe. I put it the shortly because I don't want you to write like essays. And there are two reasons for that. So the first reason why I don't want you to write essays is because I have to correct the fucking thing. And I have 190 people to correct it. So I get mad, right? But of course, I will still read it and correct it fairly, but I will still get mad, right? So, however, the most important thing is that when you write a lot, you can get a lot wrong. And I am one, so might be my only disadvantage, or this might be the thing where I am not like a nice guy, is if you write things that are wrong, I will subtract points, no matter if you got the right thing. So if I say name 3 things and you write 5 things and 2 of them are wrong, you get 1 point instead of 3 points. Because you need to know this, specifically because this is an open book exam. So I will be really hard on the correction, right? So I cannot have an open book exam and you writing down everything and getting the points. So the more you write, the more you can do wrong. So precise answers with the correct solutions only, right? Okay, shortly describe the common types of analytics in the order they depend on each other. Use one illustrative example for all types while you describe them. So there are 2 variations here. Like you can have descriptive, predictive, prescriptive analytics. This would be enough here, but you can also have diagnostic analytics. It's somewhere in between, and we said it's not really important. So this is why it's not a common type. However, it would be okay to put this in, right? Because we didn't really in the lecture distinguish. So this I would be okay with, right? But it wouldn't get any points either way. So, okay. So the first thing is use one illustrative example. Now, this is the part most people forget. They just write down descriptive analytics, predictive analytics, prescriptive analytics, next question, right? And this will only net you half of the points. Because I said, okay, you're gonna describe them shortly, right? Like describe and summarize past developments, blah, blah, blah. And then example, describe the revenue from last month by average, right? So I want to write down, this is my continuous example, revenue in a company that sells VHS recorders. It could be anything, right? You can be creative. You can do a Lord of the Rings thing and amuse me. So if the more creative you are, the better. So I will get less mad if you are creative, right? So but it doesn't really matter, but I'm just like, I like reading cool things. Because I have to correct 180 exams. So if you write something cool, then it will lighten up my day. But you don't have to, right? You can write whatever you want. Example, but it has to be an example. Like you don't forget the example, and then it's the same predictive analytics, blah, blah, blah. And then in the example, what would be predictive analytics, prescriptive analytics, what is predictive prescriptive analytics, blah, blah, blah. And then choose the optimal actions, optimizing algorithm, and stuff like this. Okay. Preparation exam solutions Q2. What are 3 common? So sometimes I actually have the number in here. And you should then look at this. If I ask for 3, you will get points for 3. If you write 2, you will get only 2/3 of the points. Very important, obviously, right? So the points are aimed at that you know all the things, not just a part of the things, right? So if I write, what are 3 common problems you face in data preparation and how can you solve them? So again, what and how can you solve them? 2 parts. There are 2 parts in the question. So missing values. So again, blah, blah, blah. What are missing values and solve? Like this can be like, you don't have to write essays. You can write one particular thing. How could you solve this? You can also have like, in case of MAR, we could solve it with blah, 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 right? So I don't expect you to write all the solutions in here, but just that I know, okay, how can you solve it? Outliers, values that are not within, blah, 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 solve. I'd acknowledge them as part of the data. So normally that occurred, but they're just data errors, remove them. Okay. Scaling. Sometimes values need to be scaled in order for analysis to put out reasonable results. We've learned this, right? The scaling. Solve, use transformation like set transform. You see, here I only used one example and it's okay, right? This is okay. Like I just need to know that you know something, okay? If the question is what are 3 ways of scaling, then of course you have to name them all, right? So just to give you an idea. All right. Okay. Or if I give you an example and you have to scale, you have to calculate. It could also be I give you, that's actually a great idea for an exam question, maybe next semester. Okay, but don't tell them, okay? So next one is the actual first thing where you have to calculate something. So until now, it's just like basic knowledge things. I think you don't have to like, you're gonna use ChatGPT for these anyway. So okay, but I would be careful. I'm going to say something about that later. Okay, assuming an underlying MIM mechanic. So I give you, usually I try to give you all the information. Like if I do not give you all the information, as always, you can write down assumption, and then this is my assumption to solve this. Like it's on you. Sometimes I think you need to write down assumptions. This is part of the critical, logical, analytical thinking, right? So sometimes you do assumption, and then you have your assumption, and I solve this under the following assumption. And then I know that this is your assumption, okay? If I've not given a detail, this is on purpose. If I've not given a detail, this is on purpose. It's not an accident. If I want something specifically, I will give you the detail. If I want you to make assumptions, I will not talk about the detail at all. Okay. So this is always on purpose because you have to like learn that not always you get all the details. Okay, assuming an underlying missing at random mechanic, so you know what kind of mechanic it is, so you should know what more means. With regard to age, what would be a good impute value for X and Y, right? So you have a data table with ID, age in years, and income in euro. And we want to find a good impute value for X. Like X is obviously an input value. You can see it right here. And now, since MAR is assumed, an informed guess would be to calculate the mean of the people in the same age group as ID5. So the thing that you have to detect here is that we have MAR, so that the height of the income value could depend on age, right? So it will depend on age since it's the only other variable in here. So that means we cannot just put in the sample mean. If you put the sample mean in here, it would be wrong, right? So what you should do is like the age group. So you can either, so there are two solutions here that are correct, right? So you could, if you are very precise, you will take ID3 only, like this one, because it's exactly the same age. Or you can say, okay, we're going to take it from the same age group, like we in our head make up age group. This would both be correct. Okay, so sometimes there are multiple solutions. So I choose income ID5 equals, so I'm going to take the 45 and the 56,000 divided by 2, and I have this value y, and then important thing is the y. Don't forget the y, please. So look at the bold thing. So y need to do this, otherwise the impute value would be biased towards younger people when MARs present regarding age. That's it, right? So that's basically it. Easy calculation with multiple results possible, and don't forget the y. Okay, okay. So preparation exam solution Q4. Now it gets a little bit trickier. So in this task, some things I want to mention. So this is the task, right? So it was also in the exam. I just printed it here so you can read it better instead of using like here. It was actually okay, but here I actually have the task here. So for here, you are given a logistic regression model to determine credit eligibility, right? So I give a logistic regression model to determine credit eligibility. So this is a new task I added because it's pretty cool because it caters more to logistic regression. So we used to have neural networks in the preparation exam, but we changed it because we didn't like, we will speak about it in AIbDSS2. So this is why I prepared you with this. So you are given, and I want to get you more tasks so you can prepare more, right? So this is something new. You are given, so I will talk in detail about this right now. So you are given a logistic regression model to determine credit eligibility, okay? So, and what you notice is, what I'm writing is, I write the parameter names, and then I'm going to write something that you can easily type, because you need to type it, right? And you cannot type theta 0, but you can type W0, right? So this is why I do this. So if you want to refer to the parameters, you can just have an easier way on expressing this. This helps you to battle the format of the online examination. So this is why I will always put this in the task, so you don't have to write theta 0 out. So you have more time, right? So you can just write this one, and the same here, and the same. So these, I just give them other names that are easier to write. But you still know that this is theta 0 in our original notation. All right? Okay. So, and then I give you values. So I give you parameter values, right? So you're given a logistic regression model. So obviously the first thing you notice that you are given an already trained model because you have the parameters here, right? So you get an already trained model. Everything is cool. You don't need to train the model, right? It just, and then determine credit eligibility. So you should know from that you actually have a model, and that then you actually have, what you actually have is you actually have here variables, like input variables. And then you know what y is. So you don't have the true value of y, you just know the nature of y, right? So nature is give credit, yes, no. And then the first task is what's the model output regarding person one, right? So, and so this is just an explanation what x1 and x2 is. So we have debt and we have income and y is give credit so that you know a little bit about the background. And now what is the model output regarding person one? And then person one is x1 equals 25 and x2 is 15. So we actually have the value. And now you have to just find out h theta of x. Now the output of the hypothesis for two persons, right? Okay, so this is the first. This is A. This is the big one. And then B is considering a threshold of 0.5. What would be a decision regarding giving credit to P1 and P2? So this is basically you get a value between 0 and 1 for both of them. And you just have to decide based off a threshold. So you see, I also give you the threshold. So there are no mistakes, right, that you can make. A threshold, what would your decision giving a credit? So you know yes, no. And yeah, that's it. Okay, would you? So one thing I would fix in the exam is I would actually give you an idea on which value is one of them. So this is a little bit sloppy from me. So in the exam, you will get give credit 1 equals yes, 0 equals no. Okay, so this I've missed here. So this is something you will not, in the exam, you will know which value 1 or 0 is yes and no. Okay, like you could assume that 1 is yes and 0 is no, but I will write it down here. So this is an oversight on my part. So I'm sorry for that, but in the exam, this will not happen. Okay, the exam is way more precise than the preparation exam. Okay, even more precise. Okay, so this is easy one. And would you use this model in real life bank? Why or why not? Okay, let's look at the solution. So the first is the big one. Now this is an example. So I wrote it down. I wrote down very many things here. So this is the large solution that you can write down. You can even write this down. So I opted for something that I can write down in the field in the online exam. So I didn't write fancy formulas, as you can see, so that you know what is expected of you. Okay. So we have here logistic regression, blah blah blah. So I wrote down this function. You don't have to. This is just a reminder, right? And then I'm going to write down this formula. So this is optional. This first thing is optional. I would advise you on doing that. Why? Because then you have the formula written down, of course. And if this is wrong, I still can give you some points here, right? So of course, if this is correct, then this is not needed. So it's a little bit risk, but it's some you have to like manage how you would do it. Okay, person one. So first, what I'm gonna do, and you should always do that, please. Like first, you're gonna first calculate the inner thing, right? The linear combination. Then you get a number, and then you just put this into Z, put this into G, and then calculate it. Please do that. Don't try to all in one statement thing it, right? I mean, if it's correct, yeah. But so, and also this way, I can give you points for that. I cannot give you points if the whole thing is wrong. You get 0 points, right? So here you can get some points for this, some points for this, some points for this, some points for this, and that's it, right? So again, so what we have here is you write down what the linear combination is. It's 0.25. Then we put it in here. We get for person one, we get 0.562. And here we get basically 0. So it's not exactly 0, but it's very much near 0. So we can write this since you need to round three decimals. And these are the values. Then you take these values and you give me an answer. Like considering a threshold of 0.5, which would be a decision. So P1 is larger than 0.5. So yes, P1 gets the credit. P2 is 0, does not get credit. That's it, right? So would you use this model in real life bank? Why or why not? And then this is the thing where you have to think a little bit, right? So what you're gonna do is this is why I wrote this down, right? So you can X1 is like the debt in thousands of dollars, right? X2 is income, right? So what's fishy here? Just you can answer this question right away without calculating anything. So look at this. You can maybe try to answer it right now. What seems fishy here? If you look at the parameters and the variables. What's fishy? Yeah, Why the hell is this positive? Like it's debt. It's bad thing, right? To have debt, right? So you owe money to someone and your probability of getting a credit gets up. Now you could discuss that the banks want this, right? So they actually can like subprime crisis you. However, in the usual model, this is very fishy. So, and this is also the answer, like, is attaching a positive weights to depth, which makes no sense. The model only takes, and also what you could also write, like the model takes only two variables into consideration. Like this is also would also be a fair, and maybe there are some other correct answers. So it's not like this is like, it's not like I'm sitting there with the sheet and saying, oh, if the people don't get this correct, then I will just not give the point. Like you should definitely catch this, right? But if you also catch something like this, then you will get some points. Okay. So it's not like if you don't get this, then there's 0 points. It's not true. There could also be other points like you could make, takes in two variables, or you could specifically say, okay, there should be other variables to consider, for example, blah, blah, blah. This would also be like, I would know that you thought about it, right? And this is also very important. So you don't get away with 0 points, but with some points here. But if you don't catch this, you will not get full points. Like this is because this is like analytical thinking. Okay. So that's it. This is like the highest level of calculation you probably need to do in the exam. So I hope you're confident with that. Okay. So as I said, you can also all do this with a non-programmable calculator. So I do not expect you to, although you can use everything, don't just a calculator. It's all right. Actually, you can do the whole exam with just a calculator probably, right? Okay. Next, Q5, discuss the importance of the learning rate using the following images. Also new task. Discuss the importance of learning rate using the following images, P1 to P4 from a linear regression gradient descent. So first, I want you to digest the whole thing. Discuss the importance of the learning rate using the following images, P1 to P4, P1, P2, P3, P4, from a linear regression gradient descent. So it's important. This is a linear regression gradient descent. Okay, so you know it's a linear regression model that gets trained. And what you get is you get an output here. And now there are questions related to this, right? So discuss the importance of learning rate using the following images from a linear regression descent. Okay, so so the first thing, so in a specific task, I will also ask you, and I thought I asked you this. So what do you see on the image is important. So discuss it is the first thing. So this is a little bit loose here. This is like a question where you need to analytically think a little bit. So the first thing I want to somehow have is what do you actually see on the image? Like there's on purpose, I didn't write down any Y or X axis things here. This is a purpose. This is on purpose. So image description, we see different iterative processes of gradient descent with different learning rates. So we have the different learning rates. Interpretation, and this is important, the learning rate partially determines how fast we go down towards the minimum of our cost function. So I need the word cost function, that we see the cost function somehow, right? The learning rate obviously plays a role. We can either be very slow, small learning rate, P1 at the right speed, P2, and then you have to like interpret the speeds, or a little too fast, so we can overshoot the minimum, or way too fast, right? So sometimes there also the right answers are double, right? So it's not always a different case. So I want to get out of your thinking. This has to be like 4 different, completely different scenarios. Like they are pretty similar, these two scenarios. Like P3 and P4 are pretty similar. And also what you can see is you should learn, like you have the learning rate and you also have the number of iterations, right? So you can argue with the number of iterations. You should see that, right? I want you to use this, right? So here we have 24 iterations, right? So this is very slow. We need 24 iterations to arrive at this result, right? Then we have here 8 iterations. This is pretty cool. We only need 8 iterations and arrive at a similar level, right? Here we have 15, so we take longer because it overshoots, and here it's way too fast it overshoots, right? And we take longer. The number of iterations tell you how long it takes. Don't oversee this, right? You can even tell me, like, we can see this a number of iterations. So I haven't included this in my answer because this is like the minimum answer required. But if you argue with iterations, I will be a very happy man, right? Because I actually, so use the things you see here. Nothing of this I give you just to ignore. Like sometimes I do, but here the number of iterations, the results, of course, the result just means that They all approach somewhat the minimum, like they are pretty similar. So you can basically ignore the result or just verify that these results are pretty the same. So we know that they all converge. Like if I give you a scenario where this is like 6 or something or 7, and you see in the picture that it actually doesn't really converge, then you can write, in this case, it doesn't converge. So this could be a thing I present you with also. But here, they all converge, although at different speeds, blah, blah, blah. We can see this from the iteration. We have different, this is caused by different learning rates. We can see the cost function. This would be a perfect answer, right? But this answer would be sufficient, right? So I expect to detect everything, but try to use like the things you see and connect them, right? And you can see also iterations is mentioned here. So iterations at some point should be mentioned here in some capacity and connected to your analytics result. Okay. So, and this is it. Okay. So, okay. Last but not least, important read. So I can tell you right now, you will get a question like this. There's no way around this. So you will get a question like this. So because it's the only thing I can let you do with evaluation, basically, right? And it gets you some points and it's relatively easy, but you will get a tricky case, of course, not an easy case like this. This is also pretty tricky, but okay. Okay, let's look at the task, okay? And again, very important, people forget to do the full task here and they miss easy points, okay? So here, I've printed it in bold for both training and validation data sets. For both training and validation. This is your first guess. You have to do this twice. Whatever I ask you, you have to do it twice. Calculate, right? Accuracy, true positive rate, true negative rate, right? You should know what these are. If not, you can use everything. Take the folder, read it. Put on the Wikipedia page I quoted. I don't care. Like, know what this is, okay? And comment on the prediction quality. So I need a comment from you. It's not enough to just calculate this. I want you to interpret the results. Obviously, this is way too easy to just let it stand on its own. It's an exam, so come on. I need you to comment on this. Okay, so and you see that I just give you 4 numbers, and so also you have to know the format, right? So this is again on purpose. So as you see, assume you are given the following confusion matrices for training and validation data sets in the formal convention of the lecture. So this tells you that study somehow how we wrote it in the lecture, okay? So this means find the page in the lecture where I taught you this, okay? Training, you can see this is it. This is the validation, and then you calculate these things, right? So accuracy, we know accuracy main diagonal, 100 plus 100 divided by everything. So 100 plus 100 plus 5 plus 25. So if you're clever, you just calculate this one time anyway. So, and this is 0.87. Nice. Okay. True positive rate. You can pretty much see that this looks pretty good already. Like this should have like the bad things are these two, right? So you see, this is pretty good. This is a little bit worse. And that's also what I want you to describe. Like you see that this is not symmetrical. Like this error is way larger than this one, right? So like the relation of false negatives and false positives is not balanced, for example. We want to know this and so on. So it might be that I give you an actual scenario like cancer where it matters, like what's false positive and false negative, the difference, okay? And then you have to interpret it. It could be. So look at this. Okay, so then you calculate this. I think this is pretty easy. Like you could just use the formulas. You should also know what they mean, like interpret this. But you can see I let like the true positive rate is okay and the true negative rate is okay, although not that good. And this is because of this imbalance, right? So this is caused by this imbalance. So write this down. Do this for the validation data also. Like you can see in the validation data, of course, the data set is smaller. It's another data set. So we have 15 plus 5 plus 50. So we have 70, and you can see it like this. So you build the accuracy, and you can see the quality is going down. Like the validation error is way higher. Like the validation error is what remains, right? Or the misclassification rate is 1 minus this. Or you can just say the accuracy is not that good. And you can see that there's a difference here, right? Furthermore, we see that the difference here between true positive and true negative rates still remains, right? It's actually the same. So we see that this still remains, right? It's still imbalanced. And also now it's way worse because the numbers are kept the same, but the general number is getting smaller, right? So, so you should comment, like, let's have a look at what I commented. So this is one possible solution. In both training and validation, TPR, TNR comparison shows that positive class recognized more frequently by the model, yes, resulting in less false negatives. Comparison to false positives, this could be a problem. False positives are very undecided. Comparison to false negatives. So this is pretty cool. So this is like a very elaborate answer. Can shorten this a little bit. The overall quality in the training set is great. With however, looking at the validation set, we see another picture. So this is important. That this you need to. This is very important. The huge discrepancy between the training and validation set led us conclude that the model overfitted the training data. This is also something you have to diagnose. Like, you remember this? Remember that thing, the graph I showed you with the bias variance trade-off? This is it, right? So we can conclude that the training error goes down, right, and the validation error goes up. So the discrepancy here between training and validation is exactly the graphic that you saw on the slide. So you should notice that. As a result, the model should be retrained with fewer epochs on the gradient descent in order to determine, so we can either have fewer epochs or we should get another model. In order to determine the best possible epoch to stop training would be to plot the trajectories of training and validation error in the plot to see where they diverge. Like, this is the thing I explained to you. We haven't explained this in detail, but as you see the graph, right? You can also argue with model complexity. You can also say may want to reduce model complexity, like the graph shows, would also be correct. Like, this could mean training a simpler model, like training a model with fewer input variables, all these things, right? So this would also be all right, right? If you don't have the fewer epochs, right? Training the fewer epochs. And also, the important thing is that this not always does help. Like, also reducing the other thing, this is something you can try, right? But this is not like a thing that will be successful. You can also formulate this cautiously and say, we could try, but success is not guaranteed. And you can never guarantee success. So I also know that you are precautious, that you know, okay, there are no wonders out there. This is also nice if I get the feeling that you are that you're a little cautious with everything. That's it. That's the preparation exam. Like, again, we will. Okay, there's a question. Let's go right to the question. Shouldn't we round to third decimal? Yes, they are free. All of them are free decimals. Is there something I missed? Oh, you mean here? I forgot the 0 here. I'm sorry. Yeah, I forgot the 1 here in the description, but it's here. Okay, so let's say, okay, instance distinguish the binary classification problem from the regression problem, and also about the cheat sheet. Yeah, the cheat sheet, I think since it's a complete open book exam, you don't really need a cheat sheet. So it's probably something I will think I will do something like putting the cheat sheet more AIbDSS2. So I think you don't need a cheat sheet really. What would I write on this? Like, you have everything available to you. I think the TPR after training was like 09. The TPR after training 952. Oh, okay. So this would be a mistake. So it's 0.952. Oh, yeah, my mistake. I will correct this. Okay. So I will calculate it and I will correct this if it's wrong. So if it's 0.952, which would be weird because yeah, you are correct. It's 0.952. You're absolutely correct. So here, sorry for the mishap. Sorry for that. You are absolutely correct. This was falsely rounded. So yeah, so it could be that this is from a time where I didn't round to 3 decimals. So yeah, okay. I'm gonna check the others and I'm gonna correct them. I'm gonna correct them right away after this. Yeah, but it's almost correct. How many questions can we expect in the actual exam? Yeah, I will come to this. I will come to this. I have a Q&A prepared for you. So don't worry. The Q&As will be here. But let me just, there was another question. Yeah, it did not figure in the prep slides. For instance, distinguish the binary classification problem from regression problem. Yeah, so I have some other questions. I wanted to give you more questions that reflect the exam. If you want, of course, sorry for that. We can have distinguish the binary classification from the regression problem. It's pretty easy. The binary classification problem sorts things, and the regression problem predicts a number, while the binary classification tries to take an object like a person or something else and tries to classify it into pre-made classes, whereas the regression problem predicts a number like stock exchange prices, and the prediction could be credited with yes or no. This would be a sufficient answer. And then usually there is a second part of that question that asks you why we can't use a linear or why we shouldn't use a linear regression for a logistic regression. Then you say, yeah, because it can potentially take on values between minus infinite and plus infinite. And this is why we have to use the logistic or sigmoid function to squeeze it down. To be within the realm of 0 and 1. And this will, for example, avoid that outliers steer the classification into a wrong direction. So this would be an answer to that. Sorry. Yeah. I will also add this, so don't worry about this. Okay. So I have some advice for you for the exam, right? So this is like some advice. If you follow it, it's up to you. So do not write novels, short and precise answer. It's open book, so you should be able. So I give you the open book, right? This is, I would say, a very nice thing to do. But I expect in return that you say that you write precise answers. So if you write something wrong, you will be punished for it, no matter if the correct is among the wrong. This is very important. I cannot stress this enough. I want you to be knowledgeable in this thing. I don't want you to be best at writing a lot of things that can be correct. So you will be punished for wrong answers, even if the correct answers are in the answers. I cannot stress this enough because it is open book. I can expect this from you if it is open book. This is simply a trade-off you have to like be willing to do. Yeah, this is it. Read all parts of the question. I just explained it. Make your life easy in calculation. So you can use anything. Like you can use any calculator. A normal calculator should be sufficient. You can also have like a second screen, a tablet, your cell phone with a calculator. So make your make your life easy. Prepare everything so you can access it easily. The time you will have a lot of tasks to do for the time. Also, it's open book, but you don't have like half an hour to search for things. Like if you are fast in searching, then you're better off, right? It is open book, but it's also a lot of things to answer, right? And if you afterwards come to me and say, oh, this was like I didn't have enough time, you had enough time, but you spent it all looking for things, right? So I actually expect you to solve this exam just with a calculator and your head. If you need something else, the time you need to look it up is not the time I give you. It's the time you need. Okay. So pretty much you sacrifice time to look something up, and then you have to be faster in other parts. Like this is just how it is. I don't give you time to search. Like I expect you to know all these things and to write it down immediately. If you need something else, you can use it, but at some cost. So you're not required to write formulas, right? However, if they help you write them down, like this was the example right here, right? Where I said, okay, you're not required to write these, but you can write them down. And if you have nothing else, I have something to give you points. Like you have to imagine this. I'm correcting your accent, like, and you write down, for example, solution 42. Like, and this is wrong. So if this is wrong, you get 0 points because there's nothing else. There's nothing else I can grade, right? So if you write down these formulas, and I think then, hey, he or she, they know something, okay? So I can create something. So do yourself a favor. There are a lot of these points in this calculation tasks, right? There are a lot of points in there. Write this down. It doesn't take you too long, and you can still get some points if it's wrong. Like if you're absolutely certain that you're that this is correct, then you don't need to, right? So it's not expected. Like the preliminary results are kind of expected, but the other thing not. I'm only interested in provisional results and end results though, so I'm interested in that. I'm interested in that. This is optional, but if you write it down and this is wrong, you could get some points for that. This is how I internally do it, right? So this is just an offer from me, right? But it's not required though. Okay, there's enough space, and money, blah, blah, blah. Okay, write down the provisional steps so I can give you more points. This is what I just said. Once again, have mercy on me, correcting 100. It's actually, I can correct this. This is now, as it stands now, it's only 186. Okay, so, yeah, so I have to correct them all on my own. So you can also expect a lot of waiting time for your grades. I'm so sorry, but correcting that amount of exams, it just takes a while, and I need to have a holiday to not go crazy. So I will be on holiday also. So and I will not do it before my holidays. Like the holidays like the week after, so I will not be able to do this in 1 week. I will try my best to do it as fast as possible, as always. General answers will not suffice. So this is also important. Precise doesn't mean general. Like I want to really that you hit it. Like just saying, oh, we need to do data cleaning. What does data cleaning mean? What do you mean? What do you need to clean, right? So this is like a bullshit answer, and I will again get mad, and this will not count, right? I want to get the feeling you can actually know the stuff. This is important. I want to get, hey, he or she, they knows it. Also, maybe you know not all the details, but you know the things and not like general things, but you know what I mean. And again, I will subtract points if things are wrong. So if you write more, the more can be wrong, right? So this is like also. Okay, what will not be part of the exam? So basically everything but PCA, of course, like we skipped this in the slides. So principal component analysis. So this was in data preparation, the last part. We didn't speak about this. I quickly described it, but this is optional. So this will not be part of the exam. There will be no task related to this, I promise, okay? Everything else you could do. And of course, you already know this, like everything you learned in the data camp exercises is not, of course, not part of the exam, right? It's not part of the exam. All right? That's not part of the exam. Okay, now exam Q&A. So I got a very nice Q&A question at 2 this morning. 2 o'clock this morning, so actually it shouldn't count, but I still, because it was so great, because it actually, I usually also have a Q&A prepared with some standard question, and this was it. Like, it was the perfect Q&A, so I actually used this one. So this is from a student. Just go through. So I have a desktop setup without the camera. Can I take the exam on the setup? Yeah. So you don't need to participate in the Zoom question. The Zoom session. Now I've questioned, sorry, in the Zoom session. So you don't need to participate in that, right? This is just optional. You can join. I provide a Zoom session. So if you want to like ask burning questions, you can. If I answer them, I will decide. If they are not related to any topic, then I might. And if some things go wrong, like you can message me. So you have a direct connection to me during the exam if you like. You are not required to join. It would be exactly the same as the preparation exam. Just it doesn't say preparation exam and the tasks will be different. It's exactly the same. You will find it on the front page of the e-learning. You click part 1, you fill out part 1, you click on part 2. You have 60 minutes to fill out part 2. You click submit or it auto submits after 60 minutes, and that's it. That is your exam. You're not required to join the Zoom session. Okay? How can I withdraw the exam on the date of the exam? Yeah, so this is not that easy because officially you can 3 days before the respective examination, you can withdraw, right? So now you can withdraw if you want. On the day, I think you have to like provide a medical certificate, but please check the Prüfungsordnung and check the examination office. I checked it quickly, and there is a form that you have to hand in to the examination office with a medical certificate attached to it, I think. But please check. The examination office has all the information. I'm not really an expert on that, but I know that 3 days before the respective examination, you can you can withdraw, I think, right? So if you don't feel ready, you can withdraw, okay? Nice. How many questions will be the actual exam? I don't know, to be honest. I haven't actually done the exam yet. So it will be around 6, I think. So like it will be like the preparation exam. It could be 7, it could be 5. I'm not sure yet. It depends on how many tasks to one topic I have. it should be around 6. The important thing is that the total workload will be fairly similar to the preparation exam, okay? So how many points is each question worth? It's different, but you can check it in the e-learning, in the exam, you can check it. Like the number of points that the question gives is on the left-hand side, right? So question 1, for example, had 9 points. Okay, I think this is all you need to know. Like right here, you can see it. I actually went into the role of a student and double checked this. So this should be marked out of 9. Okay. Do our question carry the same points? Of course not. They are different. Like it depends on the question. Sometimes it's 4, sometimes it's 10. How many correct answer points required to pass the exam? I have no idea. I collect all the grades and then I'm building my table. So the advantage is that if, let's say, I'm in a bad mood and I do a really hard exam, but everyone is bad, then I can still shift it. If I say like there are out of 50 points, 40 are required to pass, which I will not do, but then I cannot change that later. And then if the exam is hard, everybody fails. And so this is like kind of the thing that is good for you. So this is good. This is a good thing for you, not for me though, right? So because I have to do extra steps. But yeah, I think this is a fair thing. So if I like if I did a bad exam that is really hard, or if I also this also turns out if I do an exam that is too easy, this will also play out. But yeah, if I do an easy exam and you are bad in an easy exam, that this also like plays out, right? But yeah, usually it's the other way around. So or somewhere in the middle. Okay, this is my first book exam. Could you clarify this aloud? Everything. You can use everything. You can use ChatGPT. What text-to-speech tools, you can copy paste, you can use your camera, you can do whatever you want. However, don't come running to me after this and say, oh, my LLM is really bad. It's your exam. You write the exam. You are solely responsible for the results of the exam. No one else, no tool, whatever. Don't like one student said ChatGPT was down during the exam. And he said like he didn't have the opportunities like all the others because yeah, I don't care. If you need to use ChatGPT to answer the exam, then it's not my fault, right? Okay. So like it's your like you cannot blame anything or anything else. And also know that maybe as someone who teaches AI, I have a way of confusing ChatGPT in the actual tasks. That's all I'm saying, right? So your trust in the dark side misleading might be. Okay, so I will not do it on purpose, but I know some tokens that ChatGPT doesn't like, and I'm not shying away from using them. So you still have to verify your results. Okay, very important. So I will not make it that easy for ChatGPT. Okay. Will wrong answers lead to deduction of points, just like to long texts? Yes. So wrong answers of no. A deduction, I don't mean you get minus points. I mean if a task gives you 7 points, for example, right? If one task gives you 7 points, and you should say okay, and you write down like 10 things, right? So I say okay, name. Example, I say name 7 things. So this is an easiest task, name 7 things, and you write down 10 things in the hope that the 7 among them are true. Of course, 3 of them will not be true, or at least maybe they are, maybe they belong together, then it's fine. But if they are wrong and do not belong in the group, you will get the 7 points because 7 points are correct, but you will also get -3, right? What will not happen is if you write down 10 things and all of them are wrong, that you instead of getting 0, you don't get -10 points. Like 0 is the worst you can do in a task. So you don't get negative points out of a task. Okay, so this will not happen. You just get subtracted points from your basic score, but 0 is the lowest. So it will not be like you will not be that hard punished, but obviously, if you write down 10 things in the hope, hey, something correct will be there, this will not work. Like if something is incorrect and it's really incorrect and counted, if something is like neutral, then it will of course not be punished. If something is, but if you say something wrong, where I really say this is wrong, this is plainly a wrong sentence, it isn't true, then you will get points subtracted but only from this task and only from the number of points in this task. So you will not get below 0, right? This is in a task, right? This is not possible. So this is what I mean, okay? Hope this helps. Does Wolfram Alpha provide correct, accurate calculations? I would think so if you handle it correctly. Like again, it's a user problem. Like you are the user. You are responsible for your answers. Like I don't care what you use. Well, I love to use Wolfram Alpha. It's pretty cool, but you can use very way simpler tools, faster tools. I think Wolfram Alpha is a little bit too slow actually nowadays. But yeah, I'm not sure what I would use. I would just probably use a calculator or R or something, like something I have on my screen where I just quickly can type it, right? Or maybe a different device actually, so I can type it like here. It would probably be best, right? So I think this would be nice, I think. Okay. So okay. So I would think so if you connect. Okay, what if my internet connection is unstable? So the only problem with an online exam is make sure it is. I have some time overrides to join the Zoom session. I can override your time a little bit if your internet connection, but then again, I see if you're really thrown out of the exam, right? I see it, right? The problem is like if you turn out of the exam, you can just buy yourself time. So I will basically not use time override. So this is your problem, basically, right? Do we need to join the Zoom session? No, it's optional for the exam feeling. If you want to ask me questions and stuff like this, you can actually do it. Okay. So, now what I want to do is I also got some feedback from the evaluation and from the ORBA talks. So, some of you probably went to the ORBA study talks where I was also sitting there, eating the bad cookies and drinking the bad coffee. And so I was with you there, and I want to show you that at least for me, I've learned something. So I always try to improve. We always try to improve our lecture, like from the team of AI-based decision support. So from the chair of data-driven decision support. So that is us, me and my doctoral candidate. So we try to improve this, and I want to show you what we will improve and what we have learned. Okay. So some question from that. So this is mixed from the evaluation and the OPA study talk. So first of all, the evaluations were great, but we still know that we have to work harder. And I will include some of these feedback, and I will try to talk to you quickly what we will change, right? This is specifically interesting because AIbDSS2 is coming up, and we can already take some of this feedback for AIbDSS2 if some of you want to join the class to make it better for you. Okay, so the first thing is, can we do it offline to get more OPA students into contact? This was a big thing. And we need more interactive content. So I've combined these two. This is a hard one. You know me. I would love to see you in person, running around with the blackboard. But the problem is, a lot of people are. So this is only for AIbDSS1 now in the winter term, first semester. Okay, this is not true for AIbDSS2, but for AIbDSS1. I want everyone to be able to take part interactively in this lecture. And if you're not here, then you cannot take part. And it's harder for me to record it. And the quality is way worse if I record it hybrid because don't quite have technology that satisfies it. So this is good because you can watch video on demand. Like even if you have your home country, if you have like trouble accessing it, you can still watch it later, prepare for the exam. So I will try to be flexible as possible. So for AIbDSS1, we will keep it that way, right? As long as we can ensure that all the visa and processing is way faster than now, which we cannot because we are not the ones doing it. So what I can tell you is AIbDSS2 will be in person. Like we will all meet in a classroom and it will be old school because it's kind of required. We will have a lot of discussion. It's about deep learning. It's mathematically way harder. So if you're not like an ORBA student or like a computer science student, this would be rather challenging for you, but I welcome each and every one of you to join AIbDSS2, right? Maybe not all, so I don't have to correct 180 exams, but if you are all coming back, then I will gladly have you, right? So we'll be in person and so this is a comma, and next winter term. So this is for AIbDSS1 now, and next winter term for AIbDSS1. So this does not affect you because it's AIbDSS1. You're not probably gonna take it again. I will have some cumulative Q&A sessions during the semester in person. So instead of doing like the Q&As, we will have cumulative Q&As where we can meet in person, right? Once or twice a semester. Okay. So people can exchange, and then we also have some interactive content there. So we will have Q&A sessions at the beginning, and then in the second we have like a case that we will talk about. However, I have to say these will be extra, like this will be on top of the lecture because I cannot do less lectures. Like there are usually 1 or 2 days because of holidays, conferences. I'm sick, and so I have to calculate with 12 lectures at least, and so this will be additional, right? So this is the price. This is just the price. We cannot, like, I cannot cut more time. So this will be a dish, but it will only be 1 or 2 per semester, and it will be optional. So if you like interacting with other persons, you like to learn more, then you can come to these sessions. If not, well, then you miss out. And also, we will actually see who is interested in that. Like people often criticize it, but then when we provide something like talks from practitioners that are optional session, nobody shows up, right? And so this will be also for us a signal getting from you or the new cohort that comes in if you really want this or not. Okay, blah, blah, blah. Okay. If some content is optional or not, discussing that should be separated into another info document. Yeah and no. So this is a lecture, right? So I sometimes get carried away a little bit and tell you something out of my experience. So um, this is not really, there is not really actual optional content, right? So it should all be interesting to you. If not, then you're probably in the wrong class. However, I understand that if I talk a lot about other things, I should at least mark it optional. I try to do this here and there, right? So optional means not relevant for the exam, but I don't want a culture where just everybody is there. I just want to do the exam. I just want to do the exam. This is just horrible. And this is not how you should do it in a master. So I don't want to foster some culture. However, I understand this comment. And for AIbDSS2, I will try to do maybe first the important things, and then we will have like a discussion, or we have like discussion sessions with the optional stuff. So I can understand that. However, I'm a little bit torn about this, right? So I don't want to foster a culture where we just learn for the exam. That's just plain stupid. And this won't help you in life. You need to like acquire skills. You need to discuss. You need to be able to get additional knowledge, right? So it's not just like passing exams and then get a job, but you need to like be involved. Blah, blah, blah. Okay. More practical content over more general thing, but I want to address it. So this is a more general thing, more practical content. We had this thing called AI implementation seminar. However, due to reasons, which mainly is the workload of us, because I can only work so much. I'm pretty much alone in doing this all here. So, but we found like the problem is we get a lot of practice partners that actually wants us to send students to them, which you can also benefit, which is a win-win-win situation, a win for us, a win for you, and a win for the company. If you are good, it's a win for the company. If you're bad, then yeah, well, okay. But we will team up with other Oberprofs, like for example, and then we will talk about how we can organize under the realm of the scientific project, maybe groups that work on this. So we will offer more practical problems in this and under the realm of the scientific project. So not in a separate seminar. This is how I would have liked it most, but there are some administrative issues there. So I cannot ensure that everybody, for example, has done AIbDSS2, blah, blah, blah. And so we will have them, and the companies include Siemens, VW, Harry Prod, Nordsee, and so on. So it's pretty reputable companies that all have data sets for us. And so once you have this, you go into the scientific project, like after the next semester, you will probably have 1 or 2 of these tasks on your menu. So this concerns you. So I hope this will help, right? We try to work really hard, and so try to work on some way to connecting you with professionals and professional data situation that you can solve if you wish to do so, right? So, okay, so I hope this helps so that you see, okay, we're not just talking, but we immediately searched for a solution for that problem. And yeah, also, I hope this helps. And last but not least, I want to say a few words that are beyond the design of AIbDSS. And this is I want you to not think about ML because this was also a question during the over study talk, and I want to stress this. So try not to think about machine algorithms or analytical process as isolated things. They are embedded in process. Like remember, we have the deploy step, right, at the end. So we barely talk about this, but I want you to think about, so this is the system that houses the algorithm. So this is the ML algorithm. And the ML algorithm is only a part of it. Like there are other systems, like the data system. There are outside systems that either give data or get data from the algorithm. There are people surrounding this that are using the system, right? There are people maybe inside the company here and so on. So there are a lot of stakeholders that get influenced by the system. And importantly, I want you to not take an isolated look because you should be better educated. And there are some topics that we work on that surrounding this whole thing, like, for example, human AI communication. So we have algorithm aversion, acceptance, trust, right? Which is an information systems, IS thing. We have explainable AI. So this actually, we will talk about this in AIbDSS 2. Hopefully this term I will actually manage to include this topic. We have algorithmic management where actually algorithms manage people. For example, in Uber, you get deactivated if you're too bad. And this is not done by humans. This is done by an algorithm. So actually an algorithm supervises you. You're co-working with an AI. If you use ChatGPT or another engine, like AI can be like what it is to work with an AI. Like this could also be like they are related. But here it's more of a hierarchical thing, like ethics in AI, for example, in medical AI. Like, is it ethical to use this as a training data? Is it ethical to get a tumor diagnosed from an AI purely? Then new thing, prescription, prediction into prescription. So what if we use prediction optimization? Now, this is not particularly new, but this is how the two fields in OBA, they go together. Like if you're interested, this is called contextual optimization, right? Or predict, then optimize. And if you're interested to this, we offer master's thesis. So if you think, oh, I'm way into this, I want to combine the two, like the things you learn from Janis Neufeld or Marlon Ullman with the things you learn with us, then this is your way to go, right? This is your way to go. Contextual optimization, predict and optimize. We can help you with it. Write a master thesis, write a scientific project. I always have topics for this in scientific project, like since 2 years or so, and so on. So, yeah, and you can join the scientific project. Also, if you read about a topic, like Google these topics. Also, I can provide you, if you're interested in a specific topic, won't give you all the literature. Like this is a lot of literature, like 100+ papers. But if you write me a mail and say, hey, I'm interested, for example, in algorithm aversion, I read about this, I really want to do an experiment on this in my master thesis, how can I proceed? Then I would say we have a topic in the scientific project for that. Usually we have an algorithm aversion topic. Then you proceed to doing this in your master thesis. So the plan is that you do your SciPro if you're interested, of course. Like if you say, this is it, I hate him, I'm glad I've done with it, then okay, bye. But if you want to interested in doing your scientific project and then your master thesis, this is the way it should work. Like you should do your scientific project and the topic should be the same because you need to get knowledgeable in a topic. So for example, you do a literature review here and then you know the topic, or you do a programming here and then you do like a theory-driven empirical study here with your knowledge from your literature review, or you do like you provide a scientific solution to the thing you programmed, right? This is also possible. Like you write an OR paper, like specifically in this topic. So I just want to give you the whole insights. That's it from me for today. I think so. This was the last slide, I think. Yeah. So we are right on time. So somehow we've done this. So thank you so much for joining. Thank you so much for joining AIbDSS 1. I'm really glad on the turnout. We love to teach people how to do machine learning and get the whole idea of it. But don't forget, if you want, you have to like get to know this also a little bit on your own, like continue with DataCamp, continue on the internet. Like there's only so much we can teach you in a semester. It's way too short. Like even a study program would be way too short, but it would be better. So thank you so much for joining. I wish you best of luck for your upcoming exams. And of course, we will see each other if you join the exam in Zoom next week. At the exam, I will be there for the Zoom session if you want to participate in a Zoom session. It's purely optional. I've enjoyed teaching this class. I hope we see each other on AIbDSS 2. Then in person, we can discuss. We have more opportunities to interact. Yeah, and the news on this will be uploaded in the semester break, of course, once we know the room and everything. So thank you so much. See you at the exam. And now, of course, I'm open for all of your questions. Thank you so much.